Alright, Chapter 8, Inspection Procedures. 8.1. Welding joints are inspected with the two recent purpose inspections to determine the quality of the specific joints to ensure the quality of the materials applicable to specification. Weld defects are detected with the allocation of the so unacceptable parts of the weld that can be removed. Replace sound-weld metal. Second need of the weld inspection is just as important, but less frequent recognized weld inspection serve the quality control of the welding operator. The welding procedure record with the how and various types of defects occur on can show with the change of the welding procedure is needed when the poor quality of the, poor welding practices are produced being used. When the welders and welder operators should be qualified, responsible fabricator will depend on the inspection record provided with the adequate advanced notice with the welding operators need attention, but the fabricator will be able to correct the problem soon enough to prevent the loss of time and the cost of frequent repairs. 8.2. Qualification personnel. Personnel non-destructive testing must be qualified in accordance with the current requirements of the ANST, NSNT, TC 1A. Applicable non-destructive testing personnel qualified under Military Standard 410 or Military Standard 271. 8.3. Inspectors must hold up the quality of the criteria defined with the applicable specification standard for the most judgeable. Whenever the weldments are inspected to conform all the respective specifications, the inspectors must know the limitations for the testing method, material with welding process. Ideally, the inspector must also have the integrity in being well acceptably responsible for the position. 8.4. Inspection. Virtually every inspection must be made method available with the as being examined: the visual, magnetic, particle, liquid penetration, ultrasonic, destructive, leaking testing, and radiographic X-ray and radio isotopes. Acoustic emanations, the eddy current inspection have been used in producing testing, but are not being used in the field inspection. Table 8.1. List of the advantages and the disadvantages. Various inspection techniques. The method extent of the inspection vary with the nature of the work of the criteria with a certain only the following factors should be considered with the selecting of the non-destructive test methods for the welding. For the weldments, the material to be tested, joint process, geometry of the material, the possibilities, expected defects of their orientation, economical consideration. Some weldments may require a combination of the two or more inspected methods provided with the adequate evaluation. Questionable result with one of the methods obtained often may be verified with another method. Destruction testing is usually primary for the qualification of welding procedures, welders, and welding operators, sometimes for the quality control. Inspection procedure for the quality, integrity, properties, for the dimension of the material, for the components, for the can be inspected, for the methods that do not cause the damage of the following non-destructive tests methods: visual inspection, penetration inspection, magnetic particle inspection, radiographical inspection, ultrasonic inspection, leak testing. It is practically an inspect the inspection tank for the welds, root pass of the multi-pebble pass welded before the meld material is deposited with these metals, but then when the subsequent welded pass, therefore the mill likely to crack. If there is a crack, the mill propagated with the subsequent pass. If it happens to be an entire weld must be removed with the joint re-welded. It is likely expensive and require quicker to replace the defective tack of the welds root passes before the weld material is added. These welds should be inspected as soon as they are made. Follow up the inspection for the root passes. Important must be subsequent passes. They must seal the crack as tightly as that it can be detected. The visual inspection of the complete weld will indicate its sound. Alright, this shows the Table 1 use of the various inspection techniques. Magnetic particle, penetration, ultrasonic, and X-ray. Or repair and defective weld. When the defective weld is removed with the joint re-welded, the repair shall be inspected in the same way as the original weld, but the surface of the joint from which the defective metal was removed should be inspected to make sure the defective complete with the gum, but the crack should be checked with very carefully. If the part of the crack is allowed to remain, the propagated with through a repair weld, this may be avoided with a series of inspection. Metal removables may be needed. 8.5. Visual inspection. Visual inspection, which is most widely used in inspection, made with the quickly, easiest, cheapest, the only equipment commonly used with the magnifying glass 1OX or less, flashlight, or extensively other test tools such as the borescope. The density dental mirrors are often an inspection made with the visual pipe of the confined areas. Visual inspection is also required with weld evaluation. However, they will not reveal internal defects and minimal surface defects. Examine prior to the welding, before welding faces the gauges should be examined. Laminations, blisters, scabs, or seams, heavy scale or oxide films of grease, paint, oil, or dirt should be removed. Edge preparation alignment for the parts of the fit-up, but this should be checked with the welding specifications. Should be specified that all the welding joints must be inspected with the compliance with the requirements for the preparation, placement, and the consumable inserts, alignments, and fit-ups, and the cleanliness. Examine the welds during the weld, and the specification should be stated with the welds must be examined for the conformance of the qualified welding procedure. Detection of the cracks in a root pass welded bead thickness, and the slag reflex removal of the preheat with the inner pass temperatures where applicable. Examination of the welds or after welding specifications could either should state the weld must be examined for the cracks, contour, finish of the bead reinforcement, undercutting, overlapping size of the fillets, and a weld is considered acceptable for visual inspection if one, the weld has no surface flaws such as cracks, porosity, unfilled craters, crater cracks, or particularly at the end of the welds. To the welded material, base metal or viewed for the edge of the welded metals should be bent smoothly and gradually, and the adjacent base metal over there should be no unacceptable overlap or undercut. 3. The welded profiles conform with the reference standard specification. Face of the fillet welds may be slightly convex, flat, slightly concave to determine maybe unsuitable cage for the template for the figure 8.1. The minimum size of each of the fillet legs is specified by applicable drawings. Welding procedure for the butt welds of mount with the welded bead with the height of the surface of the weld with the base metal surface to show the no greater than the welding specification allowed in figure 8.2. The standards will be developed earlier with the job that should represent the acceptable borderline rejectable conditions when there are several critical joints for the separate the standards that may be prepared for each of the objective of all the inspection methods to reveal any of the flaws, defects, of any of the effective part of the surface performance. Therefore, a joint should be cleaned to remove anything that can hinder inspection. Slag or oxide films carefully should be taken with the cleaning of the method of the shot blasting and use. Final cracks and similar imperfections may be sealed, but on the surface may be invisible for the visual inspection. It is easily to correct interpretation, evaluate discrepancy in the appearance of the welds. This inspector needs to understand the welding process in order to evaluate the quality of the weld. 8.6. Magnetic particle inspection. Magnetic particle inspection, non-destructive testing, detecting cracks, seams, inclusive segregation, porosity, lack of fusion, and similar flaws for ferromagnetic materials such as steels and some of the stainless steel alloys. Method of inspection can be detect discontinuous, which is going to be defined as being seen with the naked eye, and it can also be detect some subsurface defects depending on the depth of the flaw. And the type of the inspection current with the magnetic particle inspection advantage because it can be used with the magnetic metal that is rapidly and expects from the area metal. Very reliable method by using the train inspection. This advantage for that is applied but only with the magnetic materials. Is not suited for very small DC defects are deeper. The defect is small, larger. Must be more detection. Subsurface detects the easier to find that they have the crack-like shape, such as lack of fusion in welds. Welds or rough surfaces may represent difficulties. Process sensitivity is decreased with the roughness, which mechanically interferes with the pattern formed with the iron oxide particles. Principles of the magnetic particle inspection. The parts to be inspected with the magnet is passing through the low voltage high ampere electric current, placing it in the magnetic field. Any discontinuities such as the crack or lack of confusion disrupt the magnetic field that has been established. Electrical poles from the end of the flaws and fine magnetic particles will apply with the surface of the parts attracted to electrical poles. The concentration of the particles can be seen with the flaw and located. When the easement of the magnetic flaws can be developed with the material known as the permeable, the property of the magnetic material to keep the retained magnetic field of the magnetizing current with the result of this is called retentivity. Metals which lose the most magnetism as soon as the magnetizing current is removed from low retentivity. Usually, a magnetized metal has as a high permeability, low retentivity, while metals are low permeable and has high retentivity. Construction steel generally has low retentivity. Alright, 8.1 show the gauges measuring a fillet weld contour, concave fillets and convex fillets. Alright, your fillet weld shows the leg of the leg is the side of the weld. The root is the perpendicular with the theoretical throat and face and actual throat. The two toes of the fillet weld and the original surface of the work. A groove weld is shown with the toe and the two toes at both sides with the face at the top. Reinforcement, original surface work, fusion zone, filler penetration, root penetration. Alright, your magnetic lines of force are shown on the side of your groove weld as a sound weld, and then it shows magnetic particle indication as a crack in the weld of the groove weld. DC all AC halfway rectified currents must be used magnetized high ampere to low voltage currently used and employed with the surface defects re-inspected, but the alternating current can be used. The DC issues detection subsurface discontinues perform because the current penetrates throughout the part. Maximum sensitivity provided with the using halfway rectified single phase current, but the pulsating field increased with the vertical mobility enables the particles to line up more readily to weak leakage fields. Poles peak is also produced with a high magnetizing force which is needed in the inspection of the welds. 3. Magnetic particles may be applied with the welding either with the dry powder with the suspension light oil with the particles with carefully selected with the oxide particle with the proper size and shape of magnetizing permeable retentive. The dry particles powder form may be obtained with the gray and red, black, and the contrast particles applied with the hand shakers, spray bulbs, shaking screens, and an air stream when the particles consist of the particles suspended with light, petroleum, oil, and kerosene. They can be applied by dipping and immersing and spraying the aerosol cans. These particles can be colored, have fluorescent coating with a viewing of the ultraviolet light and the particles provide with a better control or standardization concentration of magnetic particles through the control of the concentration of the suspension of the wet procedure. The more sensitive of the direct detection, extremely small discontinuities below the surface. The excess powder should be removed without stream air of the just enough to carry the excessive wave without disturbing the light of the head of the patterns. 4. A method of applying bath and particles after magnetizing the current has been turned off called the residual method. The method of applying the particles effective with the materials that was the retained magnetism, even though the high retentivity is still relatively high with the carbon and other alloys responding more favorably to this method. More construction steels, however, the low retention will not hold the strong enough magnetic field within this method. Recommended method of the construction steel with the construction method of the magnetizing done at the same time the inspection method. Particles are applied. The method is particularly using inspection low carbon alloy steels because of the low retentivity parts that cannot be maintain enough residual magnetism to help hold the particles needed to indicate the defect. Whether the wet dry continuous methods are used, inspections must be careful not to wash off the shake of the magnetic particle indications. Examination current may not be used during the magnetizing current, but many of the produce irrelevant indications because of the strong field produced with continuous metal. The method is especially used in locating surface defects. Alright, 5. When current is passed with the coil with the wrapped around the material, magnetic field is produced with the material with the longitude of the magnetism and the clamps, the prods are used to pass through the current through the material. The procedure is called circular magnetization. The two methods of proceeding magnetic fields in different directions, thereby permitting the inspector to examine the material and discontinuous in all directions. B. Equipment. The various types of magnetism equipment that are available on units of the electromagnetic permanent magnets are commonly used but are designed for locating surface cracks. Although such a unit located on some of the surface defects and the depth of penetration, several limited the direct current, but the equipment provided with the great depth of penetration needs to detect subsurface flaws. Some of the equipment both having full and half wave to redirect the current with half wave HWC. Halfway directed current, rectified direct current is particularly suitable for the dry particles because of the pulsation field provided with the extent with the mobility powder particles. Some of the most construction steels have low retentivity. Demagnetization generally not required. However, the most magnetic particles inspection units demagnetize after inspection. Or inspection procedures. The procedure describes substantially conform to ASTM E138 and ASTM E709, Military I-6868, and American Society of Mechanical Engineer Boil Pressure Vessel Code Section 5. They also outline in the inspection procedures the surface of the weld usually does not require grinding, smoothing, or the testing. However, the edges of the weld are undercut over, and if the beaded surface is extremely rough, the weld should be grounded smooth, and the edge should be lined with the base metal of the surface. Magnetic particle inspection. The surface should be cleaned of all the grease and oil, loose of the rust and water, depending because the material interface with the particles indicated the defects. Alright, 1. The prod method. Welding inspection widely used with the portable prod type of electrical contacts are pressed against the surface of the material next to the weld, as shown in Figure 8.4. The prod should not be spaced more than 8 inches apart. The short prod, spaced with a minimum of 3 inches, may be used to increase sensitivity. When the prods are positioned, the operator turns the current on and applies the magnetic particle powders. The current is turned off before the prods are removed in the order to prevent arcing. At least 2 separate examinations should be done for each after. The prods are requisitioned so that the line of the flux for the operating are approximate perpendicular to the lines of the flux for previous operation. Contact clamps can be used instead of prods. 2. The welding weld must be examined immediately after excessive powder has been removed and before position prods is changed. Surface defects appear with the sharp indication while the subsurface indication broad diffuse patterns. 3. Acceptance standards are written based on the objects intended, but the standard vary but must specify with similar limits. Most Defects. Penetration inspection. Penetration inspection is a sensitive and non-destructive method of locating minimal flaws, objects of the surface, for example, the cracks, bores, leaks, the particular available examination, non-magnetic materials on which magnetic particles inspection cannot be used. Penetration inspection is used extensively for the exposing surface detects aluminum, magnesium, austenitic stainless steel weldments, and for locating leaks in all welds. Dye penetration proceeding usually requires ground surface, although some as the weld surface can be inspected. Alright, 8.4 shows the magnetic field around the weld as the current is passed between two prods. Welding magnetic line force. Improper grinding can smear the surface and close the surface opening of the defect-efficient method. Depends on the inspector's ability to recognize and evaluate the visual indication of the flaws. Principle of liquid penetration inspection. Liquid penetration inspection, both visible fluorescent surface materials coated with the film of penetration liquid. The liquid is allowed to seep into the flaws that are open on the surface of the excess. The surface of the film is removed. The developer is applied, then they draw the penetration of the discontinued. The surface of the inspector can see the flaw. One, the liquid penetration inspection can be done quickly and easily, and it costs less than perfect with the weld inspection with any of the non-destructive methods except for the visual inspection. Initial cost of the training, equipment, material supplies, and the mess for much less than those at any other inspection method. However, the surface porosity and proper surface of the cleanness reduces sensitivity to the inspection techniques. The contamination such as water, oil, grease can be covered with full discontinuity such that the penetration does not enter. Penetration inspection is made by the use of the non-porous material. The defect of the surface. The following surface defects can be found with the penetration inspection. All types of cracks in connection with welding, grinding, fatigue of the forging, etc. Porosity, seams, laps, cold shuts, lacks of bonds between two metals. Since penetration methods can be located only with the surface defects, cleanliness is extremely important. 2. Penetration inspection is equally applicable to both large and small weldments. In petrochemical industries, pressure vessels piping, which are often made of non-metallic materials, can be inspected with the surface crack porosity. By these methods, penetration inspection can be used to detect cracks, pores, leaks through the lining in the clad of the vessel. The method can be applied with all types of welded lining. Shallow cracks of porosity can be distinguished from those extending through the lining leakers. In indication of all the cracks and porosity bleeds will all rapidly spread over the application of the dry developer. Equipment is used to penetrate the inspection of the portable aerosol cans of cleaner to dye developer and the The fluorescent penetration is used for the black light source of the 36 angstrom unit range to the hold the dark area require portable inspection kits filled with the use of commercial available. Alright, inspection procedure. The procedure describes substantially forms of the ASTM E165. Either visible fluorescent dye of the penetration method that can be used between series of the stringer welds or uncompleted weld. There are 3 types of penetration: water washable, emulsifying, solvent removable. Intermixing with penetration materials is not permitted. Procedure for the inspection depending on the specific type of the penetration method used, thereby only with the general approach is outlined in this manual. Alright, figure 8.5 shows the major steps of fluorescent inspection. Penetration of fluorescent, penetration of the surface that seeps into the cracks. Wash the spray, remove the penetration from the surface, but from the cracks and the pores. The developer acts as the blotter to draw the penetration out of the crack. In inspection, black light causes the penetration to glow in the dark. The surface must be cleanly dry. The discontinuity must be free of oil and water. Oil, water, and other contaminants such as the void of the open for the penetration can enter. The method of cleaning is the weld area. The important for the test. Proceed the penetration is applied with the surface by the spraying of the water. Brushing, and the inspector must allow enough time of the penetration to allow the discontinuity. The minimum time of the 10 minutes to temperature of 60 to 125 degrees for the normally recommended. For the smaller defects, for the higher the sensitive required, for the longer the penetration must be. Excessive penetration can be removed from the surface wipe with the absorbent cloth, either by the dry moist for the solvent, removing the surface penetration, spraying with the solvent guide with the clean surface. However, the penetration can be washed out defects if the spraying is not done very carefully. Therefore, the technique is not recommended. Alright, 5. The developer should apply with the careful so it does not produce the coat with such indications are masked. But the developer asks the blotter to draw the penetration of the surface when it can be seen with the naked eye, viewed under the ultraviolet light. Fluorescent penetration inspection. The developer may be applied as soon as possible after the penetration removal operation. The time between the application of developer and interpretation should be controlled by 6 below the true size of the difficult to appraise the dye of the diffuse too much to the developer. The recommendation practice is to observe the surface during the application of the developer in order to see the certain indication that it might tend to bleed out quickly. 6. Interpretation must be done with a specified time. The specification must indicate for the example the interpretation must be done no sooner than 7 minutes, no later than 30 minutes after the application of the developer. 7. Most acceptance standards specifically similar on limits of the crack and linear indications around indications of the specific size and quantity and number of the indication of the given area. Or A8, radiographical inspection. Radiographical inspection, a non-destructive testing technique involves taking the picture of the internal condition of the material, the picture of the produced direction of the beam of the short wavelength, radiation, X-rays, or gamma rays thoroughly with the material with the opaque with the ordinary light with the radiation exposed with the film was placed on the opposite side of the material. When developed, the film with the called radiographical that should present the absence of internal defects. Radiographical inspection is called with many of the specifications that provided with the perfect records of different types of internal defects can be identified flaws with the cracks and porosity with lack of the fusion and trap slag can be different. Radiographical inspection has limitations. However, those include with the high initial cost of the radiation has the need of the highly trained technique for the requirement of the criteria of deficiency, particularly where the cracks lack fusion, be corrected with the orientated with the respect of the beam radiation. If the orientation is incorrect, the defects will not be recorded on the film. Principles of radiographical inspection use the penetration over the power of the radiation, reveal the internal of the material radiation from the source of the pores and passive of the object, causes the change of the film, the emulsion from the film that develop the amount of dark on the film referred to as density depends on the amount of film exposure caused by the radiation penetration. Think of the thing and section the object of the procedure of radiographical testing. Shown schematically in the figure 8.6, the cone of the radiation should represent the gamma ray capsule containing the radioactive material such as those listed in Table 8.2. Not radiation penetrates the weld. Some of the absorb the amount depending on the density, thickness of the weld, and on material being inspected the cavity such as blowout hole and welded interior leaves and less material for the radiation to pass through so that the amount of the absorbed of the weld will vary to the effective region. The variations are measured on the record of radiation-sensitive film with the produced an image that will indicate the presence of the defect and implying the radiographical inspection carries is required to ensure the procedure carried out with the properly inadequate technique can result in poor sensitivity or irrelevant indications of other problems. 8.2 is the characteristic of radioscopic sources, radiation level, half-life service, half-life years, half-life value, layer, lead in inches, energy, MeV, X-ray equivalents, and cobalt CXO6, radium, cesium, rhodium, and thorium. I think I read this wrong, but... Alright, B. The equipment required for the radiographical inspection, either the X-ray machine with the gamma, the source of the film, the penetration film, the developing equipment, the viewing. The equipment is described in this below in the American Society Testing Material E94 with the table of the type of the industrial radiographic film listed with the characteristic of the table, the guide of the section of the film list, recommendation for the radiation source of the film type of the use of the various variety of alloys and different section thickness. Alright, 1. X-ray machines are available with a wide range of the size, the voltage rating, of the kilovoltage rating, required depending on the thickness and type of the metal to be radiographed. Radioactivity source of the X-ray radiation similar affect the radiation system. This is a film the difference between the X-ray rays and the original the X-ray radiation generated with the X-ray tube, while the gamma radiation is emitted with the radioactive isotope, the A tube, that gives some of the more important characteristics of the isotope. The figures of rough estimate that do show the relatively portions and position of the source and the order of their energy. Gamma radiograph is frequently construction work with the process. No external power is required, which makes it suitable for inspection for the remote areas. Cost of the equipment and source with much is less than the X-ray equipment with a comparable kilovolt range. The isotope equipment is more easily transported, but the equipment is rugged. Alright, this shows the radiographic setup. You have your source of X-rays, a window limiting cone of the radiation, cone of radiation penetration, penetrometer, weld, and filled in film in the lead back cassette. Simple operated with maintaining the confined with the space of re-inspected because of the small source of the size. However, they are several different types of the isotope sources. Among these serve radiation hazards, the source that must be stored in the lock and shield case that have handled very carefully when they are used in personnel performing the radiographic must be highly trained, must be licensed by the Nuclear Regulatory Commission. Radiographs generally have considerable less contracts than films exposed with the radiation. The cost of the trouble of replacing isotopes with the short half-lives can be factored in with deciding whether the X-ray or the gamma radiographical on radiograph radiography on project. For the image quality, the radiograph can be shown by using a penetrometer with a piece of the metal similar with being inspected is placed with the near the weld of the source of the during the radiographic to determine the degree of sensitivity to close in the radiograph. For example, the penetrometer with a thickness of 2% of the material to be inspected can be seen with the radiograph. It means the radiographic contrast sensitive to 2% with better since the radiograph technique employed was shown on the object thickness the difference of 2% or more. In most cases, 2% contrast sensitivity considered satisfactory. However, for the critical purposes such as the nuclear components of the pressure vessels and piping for the compressed gases and bridge the lower percentages desired. And now I'm back up to this drawing. Alright, this shows the Reproductive Military Handbook 55 Radiographic Non-Destructive Testing Department of the Defense 1986 copyright. Alright, all dimensions inches. T is the thickness of the parameter less than 2% of the test symbol thickness. Diameter T2, 2T but not less than hundreds of an inch. Diameter 1T but not less than 100th of an inch. Diameter 4T not less than 400th of an inch. Identification number shown with the minimum thickness of which the penetranium must be used. The numbers must be shown in the radiograph. Penetration for thickness not greater than 2.5 inches. Penetrating thickness exceeding 2.5 inches. All holes shall be true and normal and to surfaces not chamfered. Penetrators should be made material being the tested. Alright, in other classes of work, the higher pressure percentage may be acceptable to demonstrate the detail sensitivity whole of the penetrator or the diameters in terms of the F is effective. The artificial flow follows the known dimension of the holes of the are usually expressed with the thickness of the parameter of the construction details of the penetration, or shown in figure 8.7. The radiographic film must be in class 1 extra of the fine grain, class 2 fine grain. Both classes of the film give high contrast to the extra fine grain film with a small greater sensitivity of the fine grain. In review, the smaller discontinuities, however, the exposure times may be such as 5%, 50% longer than since the exposure to radiation is needed to develop an image. Film holders must be flexible. Intensification screens must be made of lead. The full screen frontal screens should be used at 5,000th of an inch, or BGAC screens at 10,000 1000th of an inch. Film processing equipment can be either manual or automatic processing system. Should be containing some separate tanks for developing short stop of the metal washing, fixing, final dryers. Must be not processing the effects. So the densometer with a denso strip is needed to make the film density requirements to have the density of the measure of the degree of the blackness, the function, exposure time, and the intensity of the radiation of the film is subject to the radiographical control of these variables. Inspection procedure. The procedure describes substantially and conforms the ASTM E94 and ASTM E142. AWSD 11 procedure also outlined the military R11470, military standard 453, and ASME boilers pressure vessel code section 5. Our radiographic must be made with either the X-ray or isotope radiation method of the level the T2 radiographical is required. All radiographics should reveal the discontinuity with a thickness equal to or greater than 2% of the thickness for the thinness or part joined with the part welding being examined in the TT designation as the first digit means T means 2% sensitivity. T2 2T, the diameter of the hole of the penetration, which must be clearly visible. Radiograph, the last one of film must be used, but the film must be cleaned with the freely processing defects. Must have density of not less than 1.5, no more than 4.0, although densities with the ranging of 2.5 and 3.5 are preferred. Radiographics will show the smallest hole of each of the penetrations specified with the specification. The radiographic identification and location welds that are radiographically need not the ground with otherwise smooth the radiographical testing unless surface irregularities interfere with desired radiographical image. When the welded reinforcement back does not remove the shim, the material being radiographed must be placed under penetration. The shims must be made the total thickness material between the penetranium and filler that at least equal the average thickness of the welding measured throughout the reinforcement backing. Alright, your parameters must be placed on the side of the work near the radiation source adjacent with the pair weld to the radiographic identification mark with the two location identification marks. Also waits for the area to show the radiograph must be placed on the material on each of the radiograph location. Alright, film holders must be placed tightly against the test item whenever possible. Shield beyond with the film holder provided with the when practical. The operator must use the radiation detection devices including the survey meters, the film edges, and isometers. Our films must be processed with the radiographics arc of high quality or of high quality films containing the mechanical, chemical, other processing effects that could interfere with the proper interpretation. Radiographic are not acceptable. Radiographics are reviewed as high intensity light source with adjustable levels of dim brightness of the penetration without difficulty. Radiograph density of 4.0. Radiographs must be checked with the proper placement, identification number of the pentameters, and all indications must be interpreted and marked. The interpreter must be familiar with the standard and acceptance with the rejection. Most standards agree with the type of the discontinuity which are not acceptable, but there are some differences. Defects such as cracks or zones of incomplete fusion or penetration because of the rejection. Porosity of one side or aggregated lengths might also be cause of rejection, while other sizes of lengths could be applicable. Acceptable. Refer to the radiographs are indicated with the ASTM E91 Military Standard 779 and ML R4577-4. Alright, ultrasonic inspection. Ultrasonic inspection is a rapid, efficient, non-destructive method of detecting, locating, measuring both surface and subsurface defects in the weldment and base metal. Ultrasonic is an energy wave of a frequency above the 20,000 hertz. The ultrasonic wave is introduced in the material being tested. Piezoelectric transducer paste from the contact with the tested specimen. The ultrasound enters the specimen and reflected back into the transducer, which encounters an interface. It could be flawed or back surface of the material. A3 shows the comparison of ultrasonic with the other techniques. Radiographic porosity, inclusion, large cracks, lack of fusion, lack of penetration, small cracks, magnetic particle, all surface cracks, large slag, penetration, fusion, subsurface cracks, liquid penetration, all surface cracks, and porosity, ultrasound, longitudinal cracks, transversal cracks, lack of fusion, lack of surge, slag, lack of penetration, show of all surface cracks, small inclusion, porosity. Could be a fall of the back surface of the material. These vibrations are converted with the two electrical symbols amplified, displayed with the cathodic ray tube. The screen indications because of the high frequency above the range of the human ear. The short wavelengths allow the small fuse flaws to be detected. Ultrasonic use most commonly be used the technique for the subsurface flaw detection. Weldments ultrasonic inspection specified to detect both internal and subsurface flaws in all types of welded joint defects with the slag inclusion, porosity, lack of the fusion, cold shuts, lack of penetration with the root defects, longitude, transverse cracks, and deconducted similarly. Only one inspection surface is usually required, and mainly type of the welding joints can be satisfactorily inspected when the flaws are found. They can be measured with evaluated dimensions such as the depth, width, and length that can be measured if and one surface is successful. Alright, principles of ultrasonic inspection. Most of the ultrasonic testing is performed with a single straight angled beam of the transducer. Depending on the design of the welding joint with the inspected the transducer, then it is referred to as the crystal or search unit of the transforming electrical voltage generated by the ultrasonic unit. Mechanical vibrations, ultrasound with the transducer also converts the returning vibration from the testing specimen into the electrical energy. They're displayed in this form on the ultrasonic unit, the CTR. They're capable of converting the electrical energy into the mechanical vibration of the backing. Again, the piezoelectrical effect of the electrical signal striking the transducer, usually not more than 1 microsecond variation, makes the transducer vibrate during the driving of the period. Duration of the pulse is short, so the return of the reflected echoes the defects. The boundaries and lying of the closed the surface will appear with the separate indications shown in figure A8, such as penetration, as is called the A-scan, and the type of the versus the amplitude with the display with the pip of the pulse, location of the CRT, timeline with the height of the amplitude with the relative depth, and discontinuity can be estimated. Alright, one, ultrasound inspection has many disadvantages over the other methods. In fast and equipment with the compact portable, like radiographic inspection, involved no time delay with the film and its process, and possesses new radiation handed to the person when inspecting the area. The indication of the flaws can be seen immediately with on the CRT. Both internal and subsurface flaws can be detected. This shows the surface cracks are more easily reliably detected magnetic particle liquid penetration. Since there are no expandable materials, the inspection can be performed faster and at a lower cost than the radiographical. Certain types of defects not readily detected with other inspection methods can be found with the ultrasonic being used. The calibrated standard with a few calculations, inspector can classify indication of irrelevant, acceptability, unacceptability. Ultrasonic inspection higher sensitivity, low level radiographic inspection. Ultrasonic inspection more sensitive to the crack detection of the material thickness, and increases the radiographical inspection opposite with the true with the table 8.3 compares the ultrasonic radiographic magnetic particle with liquid penetration inspection. Ultrasonic inspection has some of the limitations that restricted with the use of the change among the difficulty in interpreting the oscillope pattern with the need with the instrument with the calibrated with the instrument with the procedure with the produce the non-permanent and the recording show the flaws of their location. A high degree of the operator skill training is required to interpret the oscillopes patterns reliable flaws that shows the crack orientated with the parallel of the sound beam may not be detected. This means the different ultrasonic inspection techniques must be used. Alright, figure 8.8 shows the scan presentation of the cathode ray tube. It shows the amplitude, the discontinuity, the time, initial pulse, feedback, surface reflection, and horizontal sweep. 8.4 shows the frequency application charts. Surface of the material must be free with the welded spatter, must be smooth enough to allow the effective coupling between the transducer and the material. Surface around roughness can be cause scattering and absorption of the sound, although the rough surface will create an undue wear of the crystal surface of the transducer, causing the premature failure of the vicious coupling agent with such the glycerine necessary to eliminate with the compressible airs, but to prevent sound mechanical vibration for the entering the material from the transducer. The coupling agent can be any liquid grease, paste which fills surface depressions or pits. 2 important considerations selecting transducers are in diameter, operating the frequency. The higher the frequency, the greater the sensitivity will be. The advantage may be offset and lower the frequencies needed to penetrate the cross grain of the very thick materials. 8.4 shows the ultrasonic frequency range that may be used on the various applications. Transducers generally fall into 3 groups: straight beam, angle beam, and the surface wave. Longitudinal wave, sometimes called with the straight beam, directs the sound waves into the material in the direction perpendicular to the surface of the chart. The method is usually mainly detected the subsurface defects in the base metal, but should be specified with some of the welding inspections shown in figure 8.9. Alright, B, the angle beam with the method, sometimes called the shear wave, is usually required procedure for the welding inspection. Vibrational wave is introduced for the material at an angle of 30 to 80 degrees for the perpendicular for the material surface. This angle will vary material thickness as a longitudinal transducer must be mounted on plastic wedges cut in specific angles, using 70, 60, and 45 degrees, varying the position of the angle beam. With searching the unit in respect of the weld flaws in any location weld joint can be detected as shown in figure 8.10. Alright, see if the surface waves are generated with the mode of the conversion, so the refracted wave will travel along the surface. The surface waves follow the curve of the structure surface and detect surface near the surface defects. This technique has many applications in the industry, but is seldom used with welding inspection. Equipment for the ultrasonic weld inspection with a pulse echo type ultrasonic testing that can receive the present on a CRT screen pulse with the frequency range of 0.2 tenths or to 10 megahertz. 8.9 the straight beam inspection techniques used in scanning of the T-weld. Width of the inspection zone, the 3/4 active transducer width, the thorough member, the inspection zone, the attachment member. Alright, scanning procedure using an angle beam with a straight beam on the corner weld. The welded inspection zone, your 3/4 inch active transducer inspection zone. Our transducer will consist of the straight beam of the angle beam type with the frequency range from 2 to 2.4 megahertz. Angle beam of the transducer angle from 70 to 68.45 degree angles to be used with the coupling material needed with the exclude the air intake in the coupling material, including water, oil, grease, paste, glycerine. Generally, with the rougher the surface, the more vicious the coupling or agent required. Ultrasonic reference block with usually needed to check the sensitivity performance of the ultrasonic instrument with the transducer for the inspection critical welds. Most standards of the manufacturer with the artificial detects in the form of the drill holes in the flat, round, or conical bottoms of the slot machine into the surface. The American Welding Standard D1 recommends the several standards, the most common being International Institute of Welding, a reference block with shown in figure 8.11. Inspection procedures described in ASTM E7164 and AWSD11. Ultrasonic inspection procedures are also outlined with the Appendix U to the ASME boil pressure vessel code, the Section 7, Section 8, Division 1, and Section 5 of the Article 5 of the article. The ultra inspection, most important phase of the interpretation indication of the preparation of ultrasonic inspection. Operator must consider certain parameters: type of size, introducer, couplant scanning procedure, peaking techniques, frequency, pulse, and length and linearity of the indication, distance, time, relationship, sensitivity, relationship of other parameters, are specimen properties of such materials, home velocity, specific acoustic impedance, partial and geometry. Material attention noise level. Each single peak along the scan line represents a place and time where the acoustic energy has encountered an interface with multiple previously generated signal. By knowing the beam of the path spread, and the operator can interpret the signal and separate the relevant from the irrelevant indication. The operator must consider amplitude, distance, response, amplitude, area, response for determining the flaw size, the shape, orientation of flaw, also the effect of single application. Attempting to determine the flaw size and operating must watch both the flaw signal amplitude with the loss of amplitude with the back reflection. Alright, 1. Before an inspection, the ultrasonic unit must be calibrated for the sense of the horizontal sweep, the distance, the calibration block, or or recognized method must be used. Surface of welding area to be inspected must be free of welded spatter, which will also cause rapid wear with the transducer grease, restart, and oil loose scale, which will cause scattering and attenuation. Tight layers of the paint need not to be removed unless their thickness exceeds 10 rollies. A couple agent must be used between the search unit and the metal. The base metal is the first examine laminal flaws. Use a straight beam search unit and then inspect using the angle. Alright, your 811 service use of the IW block. 3/4 transducer activity wave. A12 scanning procedure for the welding of the non-ground flesh. This is a 3/4 inch active transducer wave, the scanning procedure for the welding ground flesh. Alright, beam. Whenever possible, all welds should be scanned with both sides of the beam faced with the longitudinal transverse of the discontinuity. The search of the unit must be placed on the surface of the weld of the sound beam aimed at the 90 degrees of the weld and manipulated laterally and longitudinally so the ultrasonic beam passes through all the welded metals of material. 4. The welds are not grounded flush with the figure 812 with the shear wave with the use of the 4 different scans of the longitudinal flaws sound with the directed with the weld from each of the side of the transducer is oscillated with left to right with include angles about 30 degrees to be direct transverse defects. Transducer is placed on the base of the metal. The edge of the weld is then positioned so that the sound beam makes a 15-degree angle. Longitudinal axis of the weld to the scan, searching the move along with the welded edge of the both sides of the welded ground flesh. The scanning is done similarly, but however, to detect longitudinal flaws in the transducer moving across with the welding and the transverse defect. The transducer is oscillating left to right through the 30-degree angle while the continuous advancing along the top of the weld. Alright, 5. When indicating flaws appear with a CRT location position with the transducer are recorded by using the graphs and calculators guides, and the operators can accurately locate the position of the defects of the weld by using applicable charts, attention factors that weld the discontinuity can be accepted or rejected. 8.10. Destructive testing.